This is the Physics 2 lab, Lab 1, charged tape. My name is Joshua Smith, and let's get started. Objective: this lab is designed to give students a feeling for the magnitude of excess charge that an object can have, and we use class knowledge to experimentally determine the amount of excess charge on the tape. Some important laws and formulas are Coulomb's law, that we can use the charges and the distance to find the electric force, and Faraday's concept of electric field. He also gave us formulas for finding electric field, and also using electric field to find electric force. And we'll be using those formulas in our calculations. And also we will need the force of gravity formula, which is mass times the gravitational acceleration. The experiment: to make a charged tape, we started by putting a piece of base tape on the table to serve as a common clean surface. Then we put our U-tape on the base tape, smoothed it out, and ripped it off the base tape quickly to charge it. After proving the tape's charge by testing its interaction with a hand, we proved it was positively charged because it was attracted to a negatively charged pen. We know the pen is negatively charged because that information was given to us, and we charged it by rubbing it on our hair. We suspended the U-tape over a gap and brought another U-tape close, and slowly moved it closer, and we measured the distance at the first sign of the U-tape being pushed upward. The experiment: we have our lengths on the left, masses on the right. Some notable length is that the unsupported tape was 7 centimeters, and the lower tape made the upper tape move when it was about 7.75 meters away. And the mass of the tape, using the mass given to us, 1 gram per meter, we found it to be 0.07 grams. So we use all this data. At the top here you can see we found the magnitude of the force of gravity by multiplying the mass times the gravitational acceleration to get this. And then we know at the very first instant that the tape is pushed upward, the net force is going to be 0. So we use the formulas for electric force and the force of gravity, and use that to solve for the charge on the tape. And then once we have that charge, we can plug it back in to show that the electric force and gravitational force are equal. And here is the computational model. We have a couple functions here that follow the same logic as in the calculations. A function to find the tape charge, for electric field, and for electric force, and for gravitational force. And then plug those in, make arrows out of the vectors. Also, we printed the vectors out, and this is the result right here. The red is the upper tape, blue is the lower tape, and the arrows correspond with gravity, electric force, all that. And then some important assumptions are ignoring air resistance, treating the long tape as if it were a point charge, and assuming the tape that we made had the exact same amount of charge on each U-tape. And of course, these assumptions lead to sources of error. Neglecting air resistance could affect how much tape displacement we attribute to electric force. And in reality, charged tape is not a point charge, but we treated it as such to keep the calculation simple. And also, the amount of excess charge on the two pieces of charged tape is not going to be the same, and that would require more calculation than we did. And also, there's the possibility of rounding error, how many digits we rounded to, logic error in coding. If the calculations were done wrong and we coded it to be like the wrong calculations, then obviously the code is going to be wrong as well. Handling error, poor handling could cause charge loss, which we'll go over in a little bit soon. And then measurement error, lots of eyeballing was required to measure the tape displacement due to the perspective of the human eye and the lack of precision that the meter stick measures in. And also just general human error. Humans are imperfect. So what if electrons had positive charge and protons had negative charge? In terms of charges, the charges of the tapes would remain like charges, and that would cause them to repel. So they would interact in a similar manner. However, I'm sure there are other complications due to the structure of an atom changing. But yeah, why is it important to handle the charged tapes as little as possible? When the charged tapes come into contact with other objects or hands, electrons could transfer onto the tape and cause it to lose its positive charge. This would diminish or completely inhibit our results. By handling the tape as little as possible, the risk of electron transfer and change in charge is minimized. And yeah, That is Lab 2.